Hello everyone, in this video we are going to talk about the solution for k-sorted array. So what a k-sorted array is? It is nothing but a nearly sorted array in which every element in it are displaced by at max k spots either to the left or to the right according to its position in the sorted array. I think you must not have understood what a k-sorted array means just by its definition. So let's take an example. Here it is. I say that this is a k-sorted array where k is equal to 2. So if I write its sorted order, which will be 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now I said that in k sorted array, every element is displaced by at max k spots according to its position in the sorted order. So this is my sorted order, and I say this is k sorted. So you can see 1 here is displaced by 2 position toward right, 2 is displaced by 1 position toward left, 3 is also displaced by 1 position toward left, 4 isn't displaced at all, 5 is displaced by 2 position toward right, 6 is displaced by 1 position toward left, 7 is displaced by 1 position toward left, 8 isn't displaced, and 9 isn't displaced. Alright, now as you can see, 1 is displaced by 2 positions, 2 is displaced by 1 position, 3 is displaced by 1 position, 4 is displaced by 0 positions. So this is what a k-sort array is. Alright, so let me just remove it so that we can continue our solution for this problem. So if I want to sort this array using a priority queue, first of all I need to add k plus 1 element to my priority queue. Now why k plus element? K plus 1 elements. Okay, so let's say I take k plus 1 elements here. So I have said that every element is displaced by at max k positions. So the first element coming here can be displaced by 1 or 2, or maybe it isn't displaced at all. Here you can see that 1 was displaced by 2 positions. So that's why we are taking k plus 1 elements in a priority queue. Okay, so let me create a priority queue here. So this is my priority queue. Okay, and I'm denoting this as its front. Alright, now I have put k plus 1 elements in it. So I put 1, 2, and 3 here. Now what I'm going to do is just going to remove the front of the priority queue, print it, then add next element from the array. Okay, so here you can see 1 is in the front of this minimum priority queue. So what I'm going to do is I'm going to remove 1. I removed 1, then I'm going to print 1. Now what I'm going to do is add 4. I have added 4 to my queue. Now 2 has become its front. Now same process, remove 2, print 2, and add next element, which is 6. Now 3 is the smallest element here, so 3 will become the front. Same process again, remove the front, print it, add next element, added next element. Now 4 is in the front. Again, remove front, print it, and add next element, which is 5. Now 5 is the smallest element, 5 becomes front. Same process again, removing my front, 5 is removed, then printing the removed element, 5 is printed. Now I'm going to add 8. 8 is added. Now among these 6 is the smallest, so 6 becomes the front. Now same process again, 6 is removed, then printed, then 9 is added. 9 is added. Now 7 has become the friend. Now I have taken all the elements of the array in my priority queue. But as you can see, my priority queue is not empty now. So what I'm going to do is, I'm just going to empty my priority queue to get all the elements that we need to print. Alright, so 7 is the smallest element, so 7 is going to be removed first, and new friend will become 8. I have removed the element, so now I'm going to print it. So 7 is printed. Now 8 is in the front, so 8 is going to be removed. Now 9 is the only element, so 9 becomes the front, and I have to print my removed element, so 8 is printed. Now next, 9 is in the front, so 9 is removed, and 9 is printed. Now my priority queue is empty. Okay, so as you can see, I have printed my array in the sorted order, and I have sorted my k sorted array. Now you must be wondering why I haven't put all these elements in my priority queue and printed in this order, because we know that the smallest element is always in the front of my priority queue. So if you will remember from my introduction video in the priority queue, you will remember that we have said that addition or removal of any element in a priority queue takes log n of time. So if we will add all these elements and then remove all these elements, it's going to take n log n time. Okay, for adding n log n time and for removing n log n time. And as you can see, in our question we have been given that at max we can use k extra space and use n log k time. Or alright, so if you will look closely here, we have input only k plus 1 elements in our priority queue. So it means we are using k plus 1 extra space, and all the addition in the array on the element which are added or removed from my priority queue is also from log k, because 1 is a constant, right? Okay, so now I explained you why we are doing this instead of adding all my element in the priority queue. So now let's try to code this. All right. Now first of all we need a priority queue, so we'll going to write a priority queue. Priority queue of integer. Let's name it pq. New priority queue. All right. This is my priority queue. Now I'm going to add k plus 1 element to it. So for int I equals to 0, I less than equal to k, I plus plus. Adding k plus 1 element. So pq dot add arr of I. Now simple, remove, print and add. For int I equals k plus 1, I less than n, because there are n elements in the array, I plus plus. And now we are going to remove one element and then we are going to print it. So for storing our removed element, int remove is pq dot remove. We have removed our element, now we are going to print it. system dot out dot print ln. We're going to print removed element, printed that. Now we are going to add new element, pq dot add arr of I. Now there are some element left in our priority queue, so we are going to print those while pq dot size is greater than 0. Then what we are going to do, we're just going to remove element, pq dot remove, and just print removed elements. Alright, so our program is done. Let's run it. And we have got a hit here, which means we are doing fine for our sample test case. Now let's run for all our test cases. Alright, we got 10 out of 10, which means that we have completed this program in the given time complexity of nlogk time and using at max k extra space. Alright, so that's all for this video. See you in the next one.